Hey YouTubers, thanks for checking in. If you want to know what's going on, please stay tuned. In this experiment, we're going to generate singlet oxygen by bubbling chlorine gas into hydrogen peroxide, and this is the effect that you're going to see. Let's begin. To begin this experiment, start with a 60 cc dry syringe, a needle, put a plastic cap in the bottle of the syringe. In the cap, you're going to put 1.4 cc's of 3.6 molar HCl or 1 cc of 5 molar HCl. Try not to spill it into the syringe, just keep it in the cap. Once it's in there, then you're going to draw up into the syringe some bleach. So here's our bleach, 3 cc's of bleach. You're going to put that into the bottom of a glass, and then you're going to suck the bleach into the syringe, trying not to get it into the cap that contains the HCl. So that's what we're doing now. See how the plunger has been greased so it moves smoothly? That can be done with vegetable oil or mineral oil. So now I've got the plunger as low as possible into the syringe. Now I'm drawing up the bleach, trying not to get it into the cap, because once the bleach mixes with the acid, it's going to make chlorine. So now we're going to push a cork on the needle to seal the syringe and swish it around and see what's happening here. Chlorine gas is generated and it's pushing out the plunger of the syringe. Now the plunger is moving smoothly because I greased it, and we should get at least 60 cc's of chlorine, and you can see it here, about 60 cc's of chlorine gas. I'm going to just keep shaking it until all the chlorine is completely formed, and it looks like it's about completely formed now. And make sure you do this outside just in case any chlorine escapes. Now what I need to do is get rid of the spent bleach. So I'm going to take the cork off, and then I'm going to depress the plunger so that the spent bleach is released out of the syringe. Try not to expel any of the chlorine gas out of the syringe when you do this. Then put the cork back on the bottom. Now I'm putting the syringe up against the snow because it's a cold winter's day and it just snowed. And you can see the greenish yellow color of the chlorine in the syringe. Now we're going to make a 5 molar sodium hydroxide solution by putting 2 grams of anhydrous sodium hydroxide in a beaker and adding 10 cc's of water. I'm using ice water because when sodium hydroxide dissolves in normal temperature water, it becomes very hot. So there it goes, and it dissolves pretty fast even in the ice water. Now we're going to pour some 35% hydrogen peroxide, this is 133 volume, into a beaker. We're going to draw up approximately 4 cc's of this hydrogen peroxide, and we're going to put it into a flask, a small 10 cc flask right here. Now we're going to draw up 4 cc's of the 5 molar sodium hydroxide and mix it with the hydrogen peroxide. Once these two are mixed, the hydrogen peroxide becomes kind of unstable and starts decomposing, generating oxygen. So once you've mixed these two together, and you can use a plastic straw to mix them, you want to begin the chemoluminescence experiment. So I'm just mixing it by turning the straw around, and see the oxygen forming? Now that oxygen is coating the sides of the flask, and you want to flick off those bubbles eventually. This is the setup we're going to use. We're using silicone tubing, an 18 gauge needle in the bottom of the solution. I'm flicking off the bubbles now. And there's air in the tubing, but there's chlorine in the syringe. So we're going to darken the room, and I'm going to start depressing the plunger on the syringe. You want to do it in small bursts for better effect. So initially there's just air in the tubing, so nothing's happening. You want the room more darkened. Now look at this. That is singlet oxygen forming, which is highly reactive and emits red light. It actually emits near infrared light. I'll explain why this is shortly, and it's real interesting. And It's beautiful to watch, and it's actually pretty bright. And as you can see here, I've just slowed it down for better effect. It's absolutely incredible to watch this. The light emitted by singular oxygen is 1,270 nanometers, which is in the near infrared range, which is invisible to the human eye. And the reason why we see the red glow is due to weaker transitions that occur around 634 and 703 nanometers, which are less efficient and really make up a very low percentage of the transitions, but enough that we can see it. So that kind of explains what's going on. I hope you did find this interesting, folks, and if you have any comments or suggestions, please leave a comment, and don't forget to like and subscribe. Thanks for watching, and please come back to this channel for future videos.